So in this video, I'm just going to go through some exam questions that come up on atomic structure. Atomic structure can come up on paper 1 or paper 2. The first question, it gives you a table with information about 3 subatomic particles. When they're talking about subatomic particles, they're just talking about protons, electrons, and neutrons. So you need to use this information to decide if particle A, B, and C are protons, electrons, or neutrons. So if I look at particle A, it's got a positive charge and a mass of 1. The subatomic particle with a positive charge is the proton. The subatomic particle with a neutral charge is the neutron. And the subatomic particle with a negative charge is the electron. The next question, they give you an atom of sulfur. They tell you it's got 16 protons and 16 neutrons, and they ask you why the atomic number is 16. The atomic number is the number of protons. So if there's 16 protons, then the atomic number must be 16. So you'll just say atomic number is 16 because there are 16 protons. So atomic number is 16 because you've got 16 protons. It also asks you why the mass number is 32. So if you look at your subatomic particles, neutrons and protons both have a mass of 1. If you've got 16 neutrons, that gives you a combined mass of 16. 16 protons, you've also got 16. Add those together and you're going to get 32. So the mass number is 32 because you've got 16 protons and 16 neutrons. So when you're looking at the mass number, you're looking at how many protons and neutrons you've got. But when you're just looking at the atomic number, you only care about the number of protons. The next question is on isotopes, and they give you a table with 3 different isotopes of magnesium, and they ask you to complete it. If you know your definition for isotopes, you know that isotopes have the same number of protons. So if they're telling you that isotope 24 has got 12 protons, then isotope 25 and 26 must also have 12 protons, because isotopes always have the same number of protons. They have a different number of neutrons, however, so you're actually going to have to calculate the number of neutrons. To calculate the number of neutrons, it's always the mass number, so the larger number, minus the number of protons, so the small number, so big minus small. 24 minus 12 is 12, 25 minus 12 is 13, 26 minus 12 is 14. They then ask you to work out the relative atomic mass of magnesium, and they give you the following information. To do these calculations, you take the percentage, which is 78.60, and you multiply it by the number 24. You'll then take the percentage 10.11, multiply it by 25, and you'll take the percentage 11.29 and multiply it by 26. Note, the way they've got it written here, it looks like it's minus 24, but it's not, okay? 24 relates to the mass. Mass can never be negative. So it's just a dash between the magnesium and the number 24. So you've got 78.6% of magnesium with a mass of 24, 10.11% of magnesium with a mass of 25, and 11.29% with a mass of 26. And again, you've got a different mass for each isotope because you've got a different number of neutrons, each neutron adding a mass of 1. I've worked this out for you below. So when you're doing these, it's really, really important that you show you're working, okay? Don't just do it all on your calculator and write the answer at the end. Show what you've done. So I've taken the percentage multiplied by the mass plus the percentage multiplied by the mass plus the percentage multiplied by the mass. Because we're dealing with percentages, at the end I divide by 100. I've worked out each of these individually. Again, if you just do it all on your calculator, you're likely to make a mistake. So I've worked it all out individually, and then I'm dividing by 100. When I've added those numbers together, I get this, and then I divide by 100 and I get 24.3. You are asked to give your answer to 3 significant figures, which is why I've rounded it to 1 decimal place. Okay? When you're doing these, if you are, I don't know, a little bit confused and you're worried that you haven't used the formula right, you can check your answer. If you look at your actual periodic table at the mass of magnesium, right? So if I put magnesium here, you'll see that magnesium has a mass of 24. Therefore, your answer should be 24 point something. If you're doing this and you're after getting a really big answer or a really small answer, if it looks in any way funny, then you know that you've made a mistake. So once you finish your calculation, you can literally check your answer on the periodic table to make sure that you've done it right. And if you have got something that's way out, then go back and look at your calculations. The most common kind of mistake here is to multiply these numbers. So you multiply the percentage by the large number, that's fine, but then you're adding it to the other percentage by the large number. And the most common mistake is just to multiply everything and you end up with a really big number. So you've got a periodic table in your exam, just check your answer at the end, make sure it's reasonable. The next question, an atom can be represented in this form. A is the mass number, B is the atomic number, X is the symbol. So they've given you this for lithium, so they're really making this quite simple for you, because they're telling you that the B here is the atomic number, and then they ask you for the number of protons. So the number of protons can be found by looking at the atomic number, which in this case is going to be 3. The number of neutrons is always the mass minus the atomic number, so it's going to be 4, and number of electrons is 3. Don't be put off by the way they've asked this question. All you're being asked is how many protons, electrons, and neutrons does lithium have? Usually if I was doing this, I'd always write it down P-E-N, so pen. And I'd always know that protons is a small number, electrons is a small number, and neutrons is the big minus the small number. So if that's the way you're used to doing it, then just work it out for yourself and then fill in the right number to the right box, okay? Sometimes when the exam question changes the order, protons, neutrons, electrons, instead of protons, electrons, neutrons, it can cause some confusion. So just do it the way you're comfortable with, and then fill in the answer in the appropriate space. The next one, it gives you a table and it asks you to pick the row that is correct in terms of the position of the neutrons and protons in carbon. So the neutrons are found in the nucleus, the protons are also found in the nucleus, and then electrons, which you're not asked about, are found in shells around the nucleus. So you need C, because protons are in the nucleus and neutrons are in the nucleus. The relative mass of an electron, okay, don't write negative. If they wanted negative, they'd ask you for the charge on an electron. You're being asked about the mass of an electron. And there's a few things you can say. You can write negligible, which basically means that electrons are so light, they're just insignificant. If you want to put a numerical answer on it, you can write 1 over 1840. You could also write 0.0005. There's a couple of fractions that are acceptable, like 1 over 2000, 1 over 1836, 1 over 1837. So there's a few numerical answers that they do accept on the mark scheme, but they do not accept 0. So you're either writing negligible or you're writing one of these numerical answers. The last question again relates to isotopes. In this case, they tell you the answer and they want you to work it out. So I'm using the same formula that I used above. I'm taking the percentage, 92, and multiplying it by 28. Again, that's not minus 28, that's just a dash. So it's 92 times 28. Then I've got 5 times 29, so 5 times 29. And I've got 3 times 30, so 3 times 30. And I'm adding all of these together, I'm not multiplying. At the end, I'm dividing by 100, and when you work that out, you get 28.11, and they have told you that the answer is 28.11, so you know that you're right. That will get you 3 marks, but you'll see it as a 6-mark question. So they want you to use this information to explain why the sample has a relative atomic mass of 28.11. Just doing the calculation and getting the right answer will get you 3 of those 6 marks, but then you have to explain why you're using this formula to work this out. Usually if you're getting the average of something, so if I was getting the average mass of silicon 28, 29 and 30, I would just add, if I'm normally getting the average in maths, you just go 28 plus 29 plus 30 and you divide by 3. And what the question is asking you is why aren't you doing this? Why are you using these percentages when you're working it out? And the reason you're using these percentages is because some isotopes are more common than others. So just saying that will get you a mark. You'll say some isotopes, they use the word abundant, but the word common will work either. So some isotopes are more abundant, which just means they're more common, more abundant than others. And when you're calculating relative atomic mass, you take into account how common the isotope is. So you use the percentage abundance when you are doing this calculation. So you use percentage abundance when calculating relative atomic mass. And you can see by your answer works out as 28. And if you get the average of 28, 29 and 30, you're going to end up with 29 as the average of those three numbers, but your answer here works out as 28.11. And if you look at the percentages of the isotopes, the reason is because 92% of silicon isotopes have a mass of 28. Therefore, it makes sense that the average mass is much closer to 28 than to 29 or to 30. Okay, only 3% of silicon isotopes are silicon-30, so it makes sense that the mass will be much closer to 28, and that will be your final point. So some isotopes more abundant than others. You use this percentage abundance when calculating relative atomic mass. The relative atomic mass, which I'm going to abbreviate to RAM, closest to 28 as silicon-28 is the most common. Okay, silicon-28 most common, therefore it makes sense that your numerical answer at the end is closest to 28.